Imagine a world where elephants towered even higher, their massive forms dwarfing even the largest dinosaurs of the past. It's a scene straight out of science fiction, but could it ever be a reality in our world? The answer, my friends, is most likely no, it cannot. The world we live in today, shaped by millions of years of evolution, tells us a different story altogether. Mammals, for all their diversity and success, are unlikely to ever reach the colossal sizes of their dinosaur predecessors. The reason? It all boils down to energy and its efficient use. Mammals, unlike their reptilian counterparts, are endotherms. We are the living embodiment of internal furnaces, constantly generating heat to maintain a stable internal temperature. This incredible feat of biology comes at a cost. Maintaining a constant body temperature, whether it's a frigid winter day or a scorching summer afternoon, requires a tremendous amount of energy. Think of it like this. Imagine keeping your house at a comfortable 72 degrees, day in and day out, regardless of the weather outside. Your heating and cooling systems would be working overtime, consuming a significant amount of energy. Now imagine that your house was the size of a skyscraper. Think about the sheer scale of such a structure, towering high above the city, with countless rooms and vast open spaces. The energy required to maintain a constant temperature within that massive structure would be astronomical. Every floor, every room would need to be heated or cooled, demanding an immense amount of power. The energy needed to maintain a constant temperature within that massive structure would be astronomical. This is because the larger the building, the more surface area it has, and the more heat it loses to the environment. To counteract this, a tremendous amount of energy is required to keep the internal temperature stable, especially during extreme weather conditions. The same principle applies to mammals. Just as a skyscraper requires more energy to maintain its temperature, larger mammals face similar challenges. Their bodies, much like the towering buildings, have vast surface areas that interact with the environment. As a mammal's size increases, so does its surface area. This means that larger animals have more skin through which they can lose heat. However, unlike buildings, animals generate their own heat through metabolic processes. However, the volume of the animal, which represents its overall mass and heat-generating capacity, increases at a much faster rate. This discrepancy between surface area and volume means that as animals grow larger, their ability to generate heat outpaces their ability to lose it. This means that larger mammals have a harder time getting rid of excess heat and maintaining a stable internal temperature. Their bodies are like powerful furnaces, constantly generating heat, but with their increased size, they struggle to dissipate this heat efficiently. Their internal furnaces are working overtime, but they struggle to keep up with the demands of their massive bodies. To cope, these animals have developed various strategies. Elephants, for example, flap their large ears to increase airflow and cool down. They also seek shade and drink large amounts of water to help regulate their body temperature. Similarly, other large mammals have evolved unique adaptations to manage their heat, ensuring they can survive and thrive in their environments. Dinosaurs, on the other hand, were ectotherms. They relied on external sources of heat, such as the sun, to regulate their body temperature. This fundamental difference in metabolism had a profound impact on their potential size. Because dinosaurs didn't have to expend energy generating their own body heat, they could devote more of their resources to growth. This allowed them to achieve truly awe-inspiring sizes, with some species, like the mighty Argentinosaurus, reaching lengths of over 100 amazing feet. Section 5. Eggs versus live birth, a tale of two strategies. In the vast and diverse world of animal reproduction, two primary strategies have evolved: laying eggs and giving birth to live young. These strategies are not just fascinating in their own right, but also have profound implications for the survival and evolution of species. The difference in reproductive strategies between mammals and dinosaurs also played a role in their size disparity. Dinosaurs, with their egg-laying approach, could produce numerous offspring at once, while mammals, with their live birth strategy, focused on fewer but more developed young. Dinosaurs, like most reptiles, laid eggs. This method allowed them to spread their genetic material widely, increasing the chances that some of their offspring would survive to adulthood, even in harsh environments. This allowed them to produce a larger number of offspring with a lower investment of energy per individual. By laying many eggs, dinosaurs could ensure that at least a few would survive predation and other threats, thus continuing their lineage. Mammals, on the other hand, give birth to live young. This strategy, while producing fewer offspring at a time, ensures that each one is more developed and has a higher chance of survival immediately after birth. While this strategy offers numerous advantages in terms of offspring survival, it also requires a significant energy investment from the mother. The process of gestation, where the young develop inside the mother's body, demands a lot of resources. Gestation and lactation are energy-intensive processes that limit the amount of resources a mammal can devote to its own growth. The mother must provide nutrients and protection to her developing young, both before and after birth, which can be a considerable burden. These two strategies highlight the diverse ways in which life on Earth has adapted to ensure the continuation of species. Each method has its own set of advantages and challenges, shaped by millions of years of evolution. Understanding these reproductive strategies not only gives us insight into the lives of these incredible creatures, but also helps us appreciate the complexity and beauty of the natural world. From the vast nests of dinosaur eggs to the nurturing care of mammal mothers, the story of reproduction is a testament to the resilience and adaptability of life. Section 6. Adaptability over size, the mammalian way. So, while mammals may never reach the colossal sizes of dinosaurs, they have carved out their own remarkable niche in the history of life on Earth. Our ability to regulate our internal temperature has allowed us to thrive in a wide range of environments, from the frigid poles to the scorching deserts. And while our size may be limited by our metabolism, it has also been a key factor in our evolutionary success. Smaller size means greater agility, faster reproduction rates, and the ability to exploit a wider variety of food sources. Section 7. The giants among us. Of course, even with the limitations of endothermy, there are some truly massive mammals roaming the planet today. Elephants, giraffes, and whales all stand as testaments to the incredible diversity and adaptability of mammalian life. These giants have evolved unique adaptations to cope with their immense size, from specialized circulatory systems to behavioral strategies for heat regulation. However, even these largest of mammals pale in comparison to the behemoths that once roamed the Earth during the age of dinosaurs. Section 8. A future without behemoths? As we look to the future, it's unlikely that we'll ever witness the evolution of land mammals that rival the size of dinosaurs. The age of the behemoths, those colossal creatures that once roamed the Earth, seems to be a chapter firmly closed in the book of natural history. The constraints of endothermy, which is the ability of mammals to regulate their body temperature internally, and the ecological pressures of our modern world make such a scenario highly improbable. The energy demands of maintaining a large body size in a warm-blooded animal are immense, and the current environmental conditions simply do not favor the evolution of such giants. But while we may never encounter a mammal the size of a Tyrannosaurus rex, the story of mammalian evolution is far from over. In fact, it is a story that continues to unfold in fascinating ways. Mammals have shown an incredible ability to adapt and thrive in a wide range of environments, from the icy tundras of the Arctic to the scorching deserts of Africa. Who knows what incredible adaptations and forms of life the future holds for this diverse and successful group of animals? The evolutionary journey of mammals is marked by a series of remarkable adaptations, each one a testament to the resilience and ingenuity of life. From the development of flight in bats to the complex social structures of primates, mammals have continually pushed the boundaries of what is possible. One thing is for sure: the journey of life on Earth is full of surprises, and the limits of evolution are constantly being tested. As we continue to explore and understand the natural world, we can only marvel at the endless possibilities that lie ahead. The future of mammalian evolution may not include behemoths, but it will undoubtedly be filled with wonders that we can scarcely imagine today. The story of life is one of perpetual change and adaptation, and it is a story that is far from over.